So how to actually read a book? Very basic. Many people think it's easy to read a book, but it's actually not. I recently heard a quote that a very rich and famous person is not reading books, but actually using books. And there are a few things I want to address. A book equals knowledge. A book is not just a piece of paper or a collection of papers. A book is knowledge, and it should be treated as knowledge. You should not have to read it from start to end, because that's just the way the author was trying to make the content and the knowledge accessible to you in the most appropriate way. And the last thing here is examples are examples. So don't get hung up, don't implement examples. It's just for visualizing a concept that is discussed in a book. And that's very important for programming books, in my opinion. So the suggested workflow is to understand, first of all, what you need from the book. You should not read a book, or you can read a book because you're bored, but most likely you will read a book because you need something, you need information, whether it be for your studies or whether it be for your work, where you have to read an article about how to implement a library. The second step is actually look for what you need. You don't have to read the whole book, you don't have to read the whole medium.com platform. Just look for what you need. And Stack Overflow is a great example. You're not researching Stack Overflow, you're looking exactly for what you need. And the last step is actually implement what you need. After you have understood what you need and also looked for what you need, you have to implement the information that you extracted from the book. So that's basically that's just the workflow on how to read, actually, in my opinion. And that's why it's also important, because someone said they started the book but did not finish it, and that's totally fine. If you know what you're looking for and what you need, that's okay. So now about the book, this is what it looked like. It was written by Robert C. Martin and I think some co-authors. He has very, very large experience on writing code, more centuries of years, I think. And yeah, in this book, he simply collected some ideas and principles on how to actually write maintainable and clean code. So I would like to start with a few quotes that are mentioned in the book. So if you want to go fast, if you want to get it done quickly, if you want your code to be easy to write, make it easy to read. I think it's also referenced in the book, some statistics, that most of the time a developer spends programming is not really the act of programming and writing code, but actually to read into the code base, read into the existing code, understand what's going on there. And if you are able to reduce that time, you're already creating real additional value for a company. Another quote is, you should name a variable using the same care with which you name a firstborn child. It may sound silly, but actually if you are dealing with a large code base or have dealt with a large code base in the past, you will know how important naming is. Because you will run into issues, lowercase, you have to know what case system you actually use, and if you have similar names, you're most likely to run into some pretty severe problems. Another thing is, it's not the language that makes programs appear simple, it's the programmer that makes the language appear simple. So I like this quote because it's actually really, it's an art. Coding is not just building a product, it's art. And if you put in effort to make your art or your product readable and understandable, then it's really simple, and that's how it should be for other programmers to work with. And I think the last one is, writing clean code is what you must do in order to call yourself a professional. There's no reasonable excuse for doing anything less than your best. And I also like this one, even if you're a beginner or you like to be a professional, but it doesn't really just apply to programmers or programming, but for all kinds of work you have been doing or you want to do, you have to give your best to actually consider yourself a professional and really put in effort to make everything you create as good as possible. And as Will Smith said, you cannot start building a wall. You just lay one brick as perfectly as one brick can be laid. And that's the same with code. You have to build one module, one piece of code as perfectly as you can build it, and then soon you will have a wall, or in our case, an application that will work and is also scalable. So an overview about the book, and Rob, please give me a hint if I'm going too long, because I'm not quite sure about the time. He talks about clean code in general. What is clean code? He talks about names, about functions and classes, of course, commons, formats, objects, and data structures, error handling, unit tests, systems, and he actually shows the process of refinement or the process of refactoring. Just if you want to buy the book, the examples are all in Java, but there are some excellent articles on the internet on how to transfer the concepts on JavaScript or any other language you like. But I just looked for JavaScript and they have some nice examples. I just want to touch a few key concepts because the time frame is just not big enough to talk about everything. I want just to talk about the most important stuff, or I found most important for me as a developer in my work. And the first thing I want to talk about is readability. As I said before, readability is key for good software development and also for other people to work with you, understand your code. And the first issue is names. Names should be descriptive and consistent. For example, they have an example in the book actually. You should always name your variables the way you can speak words, actually. If you cannot pronounce a variable name, that's most likely a hint that it's not a good name, for example. And also descriptive. They should describe what they are actually doing. Because many people of you, I think you have used, I don't know, for loops, and often they're using just the I that you are increasing with every loop. That's, in this case, that's okay. But other than that, the variable names should always be, it doesn't matter how long, they can be long, but they should be descriptive. They should exactly describe what they are actually doing. And another thing is to avoid mental mapping. Mental mapping is something, if your description of a variable is not concise enough, you have to check in other parts of your code what that variable actually means. You have to look in another file, you have to go to the bottom, you have to go to the top, wherever. That's mental mapping. It should be really easy to read. It should be, and that's another point here, it should be like a book. A good code should also be like a book to read. If you have a book, you start with the header, the heading, you start with an introduction, and then you read through the content. And that's the same with a code base, with a code file. You start maybe with imports. You get a feeling, okay, what is important? What is going on here? You start, for example, if you're using React, you start with a class name, stateless component. You know, all right, it's a function here. And then going through that, starting with the functions that are used later on. So defining and declaring it on top and then using it later on. And that's basically the step-down rule. You start building your code base and your files like a book, just reading it. If you can't read it and if you have to jump around in your code file, it can be improved, basically. And that's what they say in the book. So another very important concept, and I'd like to talk about, is the single responsibility principle. And this is about functions should have one and only one reason to change. The number of arguments should be as little as possible. And the same goes for flag arguments. Because I guess most of you, if you have worked as a developer, you have been using this, like you set the boolean true, and then the function does something else. And I think this is a little bit extreme, but that's also just my interpretation of the book. Maybe that's wrong. But in general, they say, use as little arguments as possible, and also focus on keeping the function as small and clean as possible. Your function should do only one thing, and you should set up your code base with little functions. Every function does exactly what it needs to do and what you expect it to do, and then you build an application with small stones, so to speak. The last thing is no comments, if possible. The authors regard comments as failure in the code. If you have to comment your code, then you failed to make it readable. Because you should, as we have discussed, you should name your variables and your functions as descriptive as possible. So if you have to add comments, you already failed. You already failed to build a readable code base. There are, of course, and this is now just really collected, of course there are some issues where comments are okay. Like for example, I think they mention legal notice or to-dos. Sometimes you put a to-do comment in your code base, that's also okay. But you should never comment out code. You should never trying to explain code, because you have to maintain comments as well. And a comment in a normal developer perspective should help you understand the code. But if you change the code and not the comment, it's not only not helping you to understand the code, but actually misleading you. And that's the worst thing ever. So try to avoid comments as far as possible. So that's about readability. Another huge issue, and I think we've talked about it the last time, is tests. How many of you are using tests or test-driven development? Okay, 3 people. 4. The authors suggest to always use, or as often as possible, test-driven development. And the way to use test-driven development, or to actually test drive your development, is to write failing tests. Just think about what the component or the function or whatever the module should do, and then write tests about that. Because you're actually building the framework for what the function or the module should do. The second step is only tests, write only tests that are sufficient to fail. You don't have to test everything, you just have to test what you want to accomplish with the component or the module. And the third step is, do not write more production code than is sufficient to pass the tests. So after you have written your tests, you build the framework, you fill the framework with code. You don't have to write extra code, because this is again not tested, and you don't want that. You want to have your code coverage as high as possible. You want to have everything tested. And they also talk about tests have to be maintained. Tests have to be maintained the same way your code has to be maintained. If you fail to maintain tests, then you again create a hole for failures, because old tests do not cover something, they do not tell you something, they just old and neglected. And with neglecting tests, you neglect the code base, and then again your code base fails and is not scalable. Also, tests are great documentation, especially with the frameworks of today. You can really write tests just as a book, and then you can just read through the tests and you understand what the module, the component should do. Again on tests, and just use one concept per function with as many asserts as necessary, but again keep it as short as possible. You don't have to test everything, just the concept that you really want to have applied in the module, for example. Another great thing, which is the last part here, which was a little bit surprising for me, is write tests for third-party libraries. If you're trying to implement a third-party library, like for example Moment.js, have you worked with Moment.js, someone? It's basically a JavaScript library for manipulating data, dates and time. And if you are integrating a third-party library, because those libraries do not have to be working perfectly, they have issues. Other people just created them and pushed them on the internet. They can have failures. And one idea is to actually write tests for this library you're implementing to see if the library itself works. This way you also understand the framework and library, and then you can implement it perfectly in your code system. So that's the idea of tests. I think I also put an acronym because they put it in the book as well, and I like it. Tests should be fast, independent, repeatable, self-validating, and timely. Because they are suggesting test-driven development, they should of course always be before production, but also just give a Boolean output. They should be fast and not depend on each other to work well. I think there's not much to say about that. One last thing about systems, because I also like this part of the book a lot. And it's also, there are many images on how to actually build a system that is independent with its modules. But the author basically says that you should organize your code for change. Because it doesn't really matter what industry you're working on or in. You probably have some feature requests. You have changes in software that's been used. You will always have change. And that's why it's important to organize your code base for change. It's also important to have a separation of concerns, to actually really divide your code base into parts where it's clear on what is accomplished here. If you have, I don't know, if you have a server that is serving something, put it there. If you have, of course, and that's just a basic example, front end, back end. Really divide it into the parts that actually, what they are doing. That's basically it. And I think we can elaborate on that after the talk, but there is much more to say about that. And of course, keep it modular. The idea is always to have it as small as possible and to use rather composition than inheritance to build an application and components out of small building blocks that can easily be taken out and switched out if you like to, but then again, keeping the rest of the application intact and working. So that's why keeping it modular is very important, and I really like this approach. Also, simple code, as a summary, should have tests that are run at all times, basically, or at least before merging it to master branch. Should have no duplication, expresses the intent of a programmer, and of course minimizes classes and methods. So that's basically everything together. Yeah, there's so much to say, but let's have that for later in the discussion. Now my key takeaways, because I'm working in different teams with different code bases, and again, code should be elegant, which means it's easy to write, and focused. So every part has a single-minded attitude. You read through it, it's easy to read, and you actually know what the code is doing, what every part is doing. So what can you take away, or what have I been taking away from this book? The first thing I was doing was analyzing our code base. At work, I was just going through it, and I was identifying code smells, or simply complicated code. If you read through your own code and you do not understand it, that's a problem. If you do not understand your colleague's code, that's also a problem. So if you find those issues in your code, try to refactor it. Also check code coverage. It's important to have your code tested. So if you change something, if you refactor something, then of course the rest of the application should be working still. Yeah, and the last thing is refactor in a test-driven way and implement new concepts. So that was what I was doing actually. I was writing tests about code base we had, because of course we had not covered everything with tests. So I was writing tests and then implement the new structural ideas, again from the book. And yeah, that's basically how I used the book to improve the workflow. So for me, the suggested workflow, because it's always difficult between theory and practice, because you have deadlines, you have a lot of issues and problems that need to be solved very quickly. So the idea is, once again, and that's a concept that is being preached, and every one of you knows this, but I think it's just important to be reminded as often as possible to do it that way, because this will spare you a lot of headaches in the future and with larger code bases. Write tests, as I said before, with test-driven development, then write the code. And now we are getting to the team experience, to the company experience, where you have the review stage, and that's amazing in programming because you have pull requests. If you are having a worked out workflow with Git, for example, you merge everything into master after you have reviewed it, after colleagues have taken a look about the code and suggested improvements. So that's a very, very critical point for a good application and a good software. And then after that, refactor your code. And it's always important to not get personal or get like emotional about a review, because review should be just to improve. It's for you to learn and for the application to be better. Yes, so that's basically the suggested workflow I've taken away from this book. There are some further reads. They are not really visible, but I will post the PowerPoint presentation. And yes, of course, I will also show you some examples, because there is a great example online. Because I haven't added code, but this looks a little bit dark. Maybe I can have it cleaner.
It's not clean.
It's not?
Not clean.
That's really not clean. Can you see something here? It's okay. I will post the link after the talk. But there is a great GitHub repository about, you cannot read it, clean code JavaScript, and they have some great examples. Like, for example, for the variables part. For example, this is, can you read that? Can someone read that? Okay, so there is just an example on how to name a date. No, don't worry. We do it after the talk. Yeah. So these are basically just examples. Yes. That was my talk about clean code. If you have any questions, feel free to ask. Thanks a lot for the attention.